So in this video, we're going to prove the next theorem. This is a theorem related to isosceles triangles. So it says if two angles of a triangle are congruent, then the sides opposite to those angles are congruent. So what we have here is basically, let's try to do a figure to know what we have. So we have a triangle, and let me use white. We have a triangle, right? So let's suppose that we have that triangle. Okay, and it says two angles of that triangle are congruent. So we have this angle congruent with this angle. Let's suppose this. I mean, you can choose the one on top, but it doesn't matter. Then the sides opposite to those angles are congruent. So it's telling us that we need to basically prove that these two are congruent. All right, remember that we have our statements, and we have our reasons. All right, our reasons. Our first statement, it's our given. Right? And our given is that, let's call this angle 1, let's call angle 2, and let's put name to the vertices. So this is A, B, and this is C. All right. So our given is that angle 1, it's congruent with angle 2, right? So this is given. All right. Okay, so basically what we need to prove is that AC, it's congruent with BC, right? If you think about it, what if we maybe we draw an altitude, a line segment that works as an altitude, okay? And we also know that altitudes form are basically line segments or lines that are perpendicular with this side, right? With the opposite side. It passes through the vertex and is perpendicular to the opposite side. And we know that if it's an altitude, we know that we can form 90-degree angles because it's precisely an altitude. Let me use a different color that we could see better. All right. So we know that these two are congruent. Also, we know that if we draw this altitude here, it's a common side in between the two triangles. So we have right triangles that has a common side, so a common leg. So we have a leg that is congruent. And by the given, we know that two acute angles are congruent. So we have leg and an angle, right? And when we have leg and an angle, in a right triangle, we know that this is a postulate. And if this is a postulate, then the two triangles are congruent. If they are congruent by CP/CTE, everything that corresponds is going to be equal. It's going to have the same measurement, right? So angles and side and everything is going to be equal. So these two sides will be equal. All right, so let's use that plan to prove this. So number 2, we just draw a line here. Let's call it CD. So CD is an altitude, right? This is by construction. All right, we just construct that line, construction. All right, let me erase these points here. All right, number 3, CD, it's congruent with CD. This is by reflexive property or common side in between them, in between the two triangles that we just formed. All right, so CD is an altitude, CD, it's also congruent with CD. All right, 4, right? These two angles are congruent and their measurement is 90 degrees. So the measurement of angle CDA, it's equal to 90 degrees, right? And it's also equal, so the measurement of, actually let's do it immediately so we don't have to, we just skip one line. So it's equal to 90 degrees and the measurement of angle CDB, it's also the same. This, it's because right angles are congruent, right? So right angles are congruent and because CD is an altitude, right? CD, it's perpendicular to AB because it's an altitude, right? So everything is equal. So obviously, basically by the same conditions that we're giving here, by the definition of congruence, then we know that angle CDA, it's congruent with angle CDB, obviously, right? This is by definition of congruency. I think that we need a little bit more space. So we know this condition, so right triangles are congruent. Let me put it here, right? And now we just put number 5 here, definition of congruence, right? Okay, number 6, if we know that this angle is equal to this angle, and we know that the leg is also equal, then by leg and an angle in a right triangle, we know that triangle CDA, it's congruent with triangle CDB, right? This is why, because leg and an angle postulate, all right? Now, let me do it over here, right? Number 7 will be basically this thing. AC, it's congruent with BC because of CP-CTE. Why CP-CTE? Because corresponding parts of congruent triangles are equal. So we just prove that the two sides are congruent. The same thing goes for other theorems that you can prove related to isosceles triangle. All right. I hope that this video is useful, and see you in the next one.